Simplify the square root of 28x to the fifth y squared. Again, our goal is going to be to factor this so that one of the factors is a perfect square. And we want to do that because then we can take the square root of that perfect square and pull out as much as we can from inside the radical. Let's start by looking at 28. We want to try and factor 28 so that the first factor is a perfect square. 28 happens to be 4 times 7, and 4 is a perfect square. So we'll put the 4 in the first radical, and then the 7 in the second radical. Next, we'll look at x to the fifth. Now, x to the fifth is not a perfect square, but it does contain a few perfect squares. Let's check this out off to the side. We know that x to the fifth has an x squared in it, so we could write it as x squared times x cubed. In that case, the first factor is a perfect square, but there's a bigger perfect square that x to the fifth contains. X to the fifth is also x to the fourth times x, and x to the fourth is a perfect square. It's x squared squared. So because we want to pull out as much as possible from the radical, we're going to end up using this factorization. So we're going to split it up into x to the fourth and x. The reason is that we want the radicand in the end to be as small as possible, so any perfect squares that exist in here we want to pull out. And if we had used this first factorization, the x cubed still contains an x squared that could be pulled out. So in this case, we've got x to the fourth times x. Now we need to look at the y's. We've got y squared, and y squared is a perfect square, so we're going to put that in the first radical. And now that all the perfect squares are in the first radical, we can evaluate those. The square root of 4 is 2. The square root of x to the fourth is x squared. The square root of y squared is just y. So we've got 2x squared y, and then also the square root of 7x. This is as simplified as it gets, so our final answer is going to be 2x squared y root 7x.